Seven Science, Mr. Paulo Silva here, recording your first video for our flipped classroom series. Today we'll be talking about forces. Okay, we started talking about forces early on term 2. We stopped to learn a little bit about mixtures, and finally we're back to forces now. I really hope you enjoy the remaining series. Okay. Well, so those are your Cornell notes. I ask you to please stop the video and you can write down your Cornell notes. For Spanish immersion students, Cornell notes in Spanish will be provided in class. So you can have a little bit of time in class to practice your Spanish and to translate and ask me any questions about the language. So please stop the video now and make your notes. Okay, so back to forces. What is a force? Force, the dictionary says that the force is a push, a pull, or twist. And you know that the forces are measured in newtons. So this image here must be very familiar to you. We finished talking about forces earlier in the term. We described something called the force of gravity. That's D here. Then we described also something called the normal force at the very top there, a B, the drag, C, and the acceleration, which we should call it A. So in this case, when you're riding a bike, there are a number of forces acting upon your body, but we never think about it. Now you have an opportunity to learn more about those forces with us. Types of forces, we'll be talking about applied force, gravitational force if we have some time, normal force, and frictional forces. If you want to be extended, we can talk about the other ones listed on the screen. Vectors and scalars. Please have a look at this compare and contrast image. Remember, that's a revision. We talked about something very important called vector, and we also talked about scalars. They both have magnitude and size, but the difference is that vectors, they have direction, whilst scalars, they don't. Vectors, they give you displacement, while scalars gives you distance. Therefore, scalars will give you a speed of a moving object, whilst a scalar will give you a velocity. Those are two very distinct things. So let's use an example here. Imagine that you're sitting in your lounge, and you can see in the image that you have different directions, but I'm not specifying which direction is north, which direction is south, and etc. At the very same time, you imagine that this little rectangle here, it's around 1 centimeter across. So now you take a baby and you put that baby inside a box. The baby is all happy playing inside the box, and you decide that it would be a good idea to move that baby around the room, and you decided to move in a certain direction. There he goes, very happy. The baby moved a certain direction at a certain rate, but you actually don't think about the direction. It just moved. The distance traveled is around 10 centimeters. We are talking about distance here. Distance is a scalar. Now, that's the definition of distance. Distance is a scalar quantity that refers to how much ground an object has covered during its motion. Please write that down. That's the speed equation. With that equation, you can find out the speed of a moving object, the distance, or its time. We'll do an exercise in class to revise that skill. Now, please pay attention to what's happening at the very top of the page there, of the screen, the right corner. You've got a compass. A compass will give you directions. the points, north, west, east, and south, and the smaller points between them. So now, imagine that you have an egg with a chook inside, and that you want to move that egg at a certain direction. Then we ask the little chook to move inside the egg, of course. The distance covered is also 10 centimeters, but because we know that there is a direction applied to the movement, we have a displacement. The displacement is around 10 centimeters east. Displacement is a vector. Please write that down. That's the definition for displacement. A displacement is the shortest distance from the initial to the final position of a point. I'll show you a couple of examples now, and you'll be able to understand what displacement is. Okay, that's a very, very good image. The distance covered by a moving object is demonstrated by the blue line, whilst the displacement is shown by the red line. The distance, you have to have that in mind, that the distance can be 5, 10, 15 times greater than the displacement. We'll have some examples here and a formula, and you'll be able to understand what I'm talking about. The formula for displacement is delta x equals to fx minus x0. No need to be scared, okay? Delta x is the symbol used to represent displacement, change in position. Fx refers to the value of the final position. F is for final. X refers to the value of the initial position. X0, so it's basically where you started.